So in this video, we're going to talk about this newer concept called Agentic RAG, what it means, and also we're going to learn how to use a framework called phidata, which allows to quickly create Agentic RAG flows. Now, before we start with the setting up phidata RAG, Agentic RAG platform for us to see everything, let's go ahead and look at the motivation behind Agentic RAG. Because when we say Agentic RAG, of course, we are implying that we need to add some agents inside of these RAG systems. And so we're going to look at the difference between Agentic RAG and normal traditional RAG. Now let's go ahead and do a quick dive into RAG. So what is a RAG system? So a RAG stands for Retrieval Augmented Generation. What that means is that we would have documents coming in. We go through this parsing and pre-processing, and these documents that are parsed are then chunked into smaller pieces, which then are passed through an embedding model. So that could be any model that is able to create those embeddings, which then are vectorized and added into a vector database. And so this part here, all of this process is what we call indexing, right? Because we pull in information, chopping it up, in this case documents, and then put all of that stuff into a vector database. So we are transforming or changing the chunks of documents into embeddings, which are then added into the vector database. So this is all indexing. And so the idea here is that you have a user, which also would have a query, a question, and then that is passed through also the embedding model, because this information has to be transformed into embedding a vector, the vectorized information data, which then all that is passed through the vector database to do similarity search to retrieve documents that are relevant, so that those are part of this augmented side of RAG systems, which means we have the prompt, those pieces of documents, relevant documents, and then the query, and then that is all passed along through a large language model, which then is able to infer that information and give us the response, generate the response. So this is what RAG systems really are. This is how they work. Now I'm going to make this a little bit more generalized, as you can see here. So the idea is very simple. Again, the same thing that I had before. This is just a more compact diagram. So we have our user. Of course, we have the query. It goes through embedding model or large language model, putting everything in one place, really. And then all of that is put into a vector database. But on the other end, also we have these docs that goes through the indexing side of things, and we chunk them up. We put all of that information into a vector database. So that is the system here. So what happens now is that, again, the user passes in a query, which is transformed into embedding, so that we can go through the vector database, and then we're able to use a large language model to get the answer, because at this point we should have all the information we need, relevant piece of data, as well as the query and all that, to return a response. So again, same thing I showed you, but in a more compact way. Now, what is the difference between what we see here, which is a traditional RAG, from a agentic RAG? So the agentic RAG is a little bit different in that now we add another agent, which essentially is actually a large language model, a model that allows us, we can call anything. In this case would be a retrieval agent. This retrieval agent has a lot of few responsibilities. Okay, so the first responsibility that it has is to query decomposition, which means it's able to get this query, this question that it received from the user, and create smaller or different categorized questions, so that those questions are actually going to go through the vector database and retrieve the correct information that's needed and pass that along into the large language model to get the response. Now, the retrieval agent here is just one. We can have more than one agent. So that's why it's agentic, because now we're using agents or an agent to do more things to make it so that the relevancy of the data that's going around is really optimal, so that the large language model is able to retrieve, and in this case, it's able to create or generate the right response, right? The most accurate, most robust response. And so we can also rewrite queries. So this agents or agent could rewrite the query that was passed along, can also find relevant documents that were said before, and also check for hallucinations. Because as we know, large language models are real good at hallucinating or making stuff up when they don't know what the answer is, as well as the ability to call other tools that may be needed to get to the answer. So the whole idea of having this agentic RAG system, adding agents into the workflow, is that so that we have a pipeline, a workflow that is more responsive, accurate, and adaptable. That is the whole reason, right? So again, I just have one agent here, but you can have multiple agents that are doing different things. One thing to keep in mind is that when we have these agents, we're literally passing in or calling a large language model, which means the more agents you have, the more calls to the large language models you will have to make, which might also something to keep in mind, because the more calls you make, that means the more cost will incur. Right, so now we understand the difference between traditional RAG and agentic RAG. Okay, we understand the reasons why we would want agentic RAG. Let's go ahead and use a tool, which is one of the newest tools, frameworks, I should say, called phidata, that allows us to create this create agents actually on the fly, especially also creating agentic agents or agentic RAG systems on the fly. So let's go ahead and get started. All right, so if you go to phidata.com, this is what you're mostly gonna see. So how engineers build AI agents. So very cool. There's a lot about this. I'm not gonna go through everything. Maybe in the next videos or so, if you want me, I can go deeply into building AI agents using phidata. So it's a new framework, new AI agent framework or platform. So we can go ahead and say get started here. So this brings us to the documentations. Okay, so there's a lot going on here. You can go ahead and click and open to get more information here. All right, so let's go ahead and say, so agents are autonomous programs that complete tasks using language models. Yes, we should know this by now. It talks about what is phidata. It's a framework for building agentic systems. Engineers use phidata to build agents with memory, build teams of agents that can work together, chat with agents using beautiful agent UI, and all these great things. Okay, so how to get started? Well, we have instructions for Mac and Windows. How awesome is that? And so if you're Mac, of course, you go ahead and get started. So you create the virtual environment first, and then you activate it. You should know how to do this, but if not, go ahead and do that. And also we have for our Windows friend. And also we have Windows option here. Okay, let's go ahead. I'm on a Mac. I already have created the environment and everything. Let's go ahead and start the installation. So I'm on Mac, click on Mac, Windows is over there. Okay, Mac, come here. I'm gonna go ahead and, okay, so I already have that installed. So that was really quick. And they also say that phidata works with every large language model that's out there, but this example is going to use OpenAI. So that's what we're going to use to make this simpler. So you would say export OpenAI API key and pass it along like this. If you're on Windows, that's what you do. And also what you can do is go to your project and create the .env file and do that manually. That works as well. Okay, so I already have that. And if you want, you can go here to get your OpenAI API key. Okay, so the first thing we're going to do is real quick create an agent that will go and scrap or use from the web. So they have everything here. I'm going to go ahead and copy all of this real quick and get started. So let's go to our project here, new file. Let's say web search. Let's just call web agent.py. And then let's go pass it all in here. Okay, so what's going on here? It's very simple. First of all, we're using py or phi agent. So we're importing the agent from phi agent. And then we are, because we're going to be using OpenAI, we are importing, in this case, the OpenAI chat there. So we can use that. And of course, we are using the DuckDuckGo search engine to get all this stuff. So this is the dependency that we're passing in. Okay, so to create the actual agent is very simple. As you can see here, it's an agent, and you pass the name, web agent, or whichever name you want to add. And we need to pass the model that we're going to be using to actually sustain or get this agent to run. So we're going to use the OpenAI chat, which we imported here. And then inside here, we pass the ID. So in this case, I'm going to say GPT-40, and I'm going to actually make it mini for simplicity. You can use the full one, but mini, it's fine. And then we can pass tools. Now the tools in this case is going to be, as you saw earlier, these are tools, these are functions, these are other functionalities that we can attach to our agent. So it has more of a toolbox where it can go and use certain tools to do certain things. In this case, it's going to use DuckDuckGo to do the web searching and all that. And we pass instructions here as a list or an array. So we can make this more, but this is fine. Show tool calls. This is true, so we can see in details if the tool was called or not. Markdown true, so we have nice markdown and everything. So then we just say web agent print response, and that's when we pass, in this case, a question. So say what's happening in Lisbon. And here we're passing stream to true to say we want the results to be streamed, not just waiting for all the response and then show it. We just stream it along. Okay, so that's about it, but that's not about it, because then we need to pass a few other things. One of the things that we need to pass, or in this case, we need to install the DuckDuckGo search. So I'm going to go pip install DuckDuckGo search. I already have that. That's why it was fast, and that's clear. Let's go ahead and run this. We should be able to run this and see how it works. So I'm going to say Python 3, and let's run, and voila, you can see it's now thinking. Messages what's happening in Lisbon, and it gives us the seconds, milliseconds, or seconds in this case, how long it's taking to go through everything until we get the whole result. Okay, so it was really fast. As you can see, it was about 8.7 seconds. And running, it tells us it went ahead and used a tool called DuckDuckGo News and passed in a query Lisbon, and internally says max results is 5, and the query is what's and then we have here's what's happening in Lisbon, right? We have the supporting Lisbon, and these are all links because we asked to show the resources. Very good. So this is actually working. We're able to put together really quickly an agent that is able to search the web. Now it's very simple. I kind of like this because it's not that complicated, and you can see, if you've been following me along, you can see that the same structure of creating agents, it's pretty much usually the same in different platforms or frameworks. This was a nice introduction, quick introduction to phidata agents. But what we want to do is we want to use phidata to actually create Agentic RAG. That was the whole point. How do we do that? Well, the first thing I'm going to do, of course, is I'm going to go ahead and create yet another file here. Let's call this Agentic RAG.py. Now, if you remember what an Agentic RAG would look like, is that we are actually not going to just push ourselves the context of what needs to be passed through the large language model to get the result. We want to actually use an agent to do most of the work, right? To make sure that to do the query decomposition, to split up into small different queries, questions, and all that stuff. So we're going to focus on that first one because it's just easiest. So how do we do that? Well, they make it really, really easy. I have the code here, and so let me go ahead and paste a few things. So you can see here, we're going to go get the agent. We also keep going and get the model, which is going to be OpenAI chat. We need an OpenAI embedder or any kind of embedder, really, remember, because we still need to create embeddings. And then in this case, we're going to save into a database. And the database we're going to be using is LanceDB. It's very native to phidata. And then we have the PDF URL knowledge base. As you will see, this is going to allow us to go and get a PDF file from somewhere, which we are going to extrapolate the information and then pass through the embedder and do all the things, and then eventually save into local database. Okay. Next, we're going to go ahead and create a knowledge base from the PDF file. Okay, so we have the code here. So knowledge base, we use the PDF URL knowledge base class, and then we pass the URLs. Obviously, we could pass more than one PDF file, but in this case, we're just going to use this one here. Now, inside of this knowledge base here, we pass the vector database because we're going to use the LanceDB as the vector database. Now, you can use any kind of database that you want, but in this case, we're going to use this local one. We instantiate the LanceDB. We pass in the recipe name. You can name whatever you want, and then the URI. So locally, where do we want the LanceDB to be? So it's just going to be in temp/LanceDB. And the search type here, we say search type vector. Now we have different kinds of search types. We have hybrid, keyword, vector, and so forth. So I'm going to use hybrid because it's a little bit more powerful, hybrid. And then the embedder needs to be passed because this database is able to push in the information, get the actual recipe. And then what happens is that we are going to use the OpenAI embedder. With the model we're going to use is going to be the text embedding 3 small, which is a little bit smaller, and we'll get the job done. Okay, and that's it. So in this case here, we now have created a knowledge base from this PDF file that we passed along. Now, once we do that, we then call knowledge base, which is what we created here, load. Okay, so in this case here, once we run the first time, you would want to comment this out. But what you can do also, you can say upsert to true. What does it do? Well, if you have over, upsert. If true, upserts documents to the vector database. So defaults, it's usually false. So this should be good. Okay, so we have the agent here. So again, you create an agent and you pass in the model. We're going to use the OpenAI chat and we pass the model. I'm going to make it this mini, GPT-4 mini. In the knowledge base, this is important. We want to make sure that this agent has the knowledge base to use as it goes through the process of generating the response. And likely we have the knowledge base, which we have loaded, we created here, and we're loading the knowledge base. Okay. Now show tool calls to true, markdown also to true. So next, let's go ahead and use our agent and pass in a question. So I'm going to say, for instance, print a response. How do I make chicken and galangal in coconut milk? Now, this is just a generic example, and we pass in stream to true to say we want is the answer response streamed. Let's go ahead and run this real quick. And so what we'll do, you can see here, it goes ahead and creates the collection, and you can open here. You can see now we have this temp that was created here. Make it a little bit larger so you can see. The temp was created, and soon enough, you can see it's doing all the things. And then inside, you can see that has this data now. So this data here is part of the database, okay, created internally. So now we should have all the information that we are looking for. So you can see it went ahead through the process of creating collection, loaded the knowledge base, and it started reading from our PDF file that is in the cloud somewhere. And so it tells us added 14 documents to the knowledge base. Okay. Thinking, I think this is just some sort of repetition here, formatting issues. And so how do I make chicken and galangal in coconut milk? And then it goes through running. It goes and search knowledge base because that's the whole point, and passes in the query, which is exactly what we passed. And then the result is this one here. So keep in mind that essentially we went through that process that I showed you in the beginning where we have a RAG system put together. So we went ahead and got these documents, chopped them up, and then vectorized them and added into the database. Okay, and when we ask questions, the same process happens. The question goes through the vectorization and all that stuff. And then we do this search into the database to pull out the correct or relevant documents so that we pass all of that into the large language model so that we have the response which you see here. But now you will see something here. I'm going to put a different question that is a little bit more involved. So now I'm going to say, hey, I want to make a 3-course meal that would include a Thai dish as the main course, some soup, and then dessert. Let's go ahead and run this real quick and see. Okay, you can see it goes ahead and created a collection and did all these things, reading from the recipes.pdf, and says here added 14 documents to knowledge base. Okay, And so now you can see here's a suggestion for a 3-course meal featuring a Thai main dish, soup, and dessert. So see here we have tom tom soup, tom yum soup, and the ingredients, instructions, and then we have the pad thai. Now let's see something interesting. I'm going to go ahead and copy this starter here. I'm going to copy this, and then I'm going to go to the actual recipe PDF, this one here. I have it opened, and then I'm going to see if I can find that. And you can see in my searching in the file, it does not exist. So I don't have this tom yum soup. What does that tell you? It tells you that this agent is not focusing only on what we have, the knowledge base. That can be problematic because now we see the agent is going on its own and finding its own information from its trained data. But that's not what we want. Okay, this is a good example. Now, how do we change this? How do we make this more of an agentic RAG system? Well, it's very simple. So to make this agent even better, in this case, to be able to only use or to use agentic RAG workflows, all we do is we say, so I say search knowledge and give it to true. This, my friend, is what makes this a true agentic RAG. You will see what happened. Let's go ahead and run this one more time. So the same thing is happening, but something else is going to happen. Okay, and voila, you can see now it's doing what an agentic RAG would do, which is we have this decomposition, this query decomposition. So it broke into 3 items. So you see, called search knowledge base, passing Thai dish main course recipes, and then it broke it down to say still go ahead and query find soup recipes. And then it went ahead and say go and find dessert recipes. It has to be within this context, within our PDF file. And look at that. Now we have this tom yum goong, and we have directions, and then we have this pad thai goong sod, and all of that. Okay, and the dessert. Now I'm going to just copy this and see if we can find now in our PDF file. We should. So if I go and Command F and paste, voila, you can see that we have one of 2. This one here, Khao Niem Dam Peak Mafrao on. Okay, probably butchering that. And just like that, ladies and gentlemen, you can see that it's actually going and getting from the PDF file. This is huge. Not only are we sure that this is not hallucinating or grabbing information from its own knowledge base, in this case, a large language model, we know for sure that it's only getting information from our RAG system, from our documents. And you can see the beauty here is that if you have a system that needs to be limited only to what you provide to it, which is ideal, then this would really be helpful because you want to ask questions and get the correct answers that are pertaining to that document, not any hallucination from the large language model. All right, so this is huge. And there we go. And that's what we have here. You can see exact thing that we said Agentic RAG should provide, which is this query decomposition as you saw here. There are other things as we discussed, but this is the number one thing you can see. You can see the difference between a traditional RAG and this Agentic RAG. And there you have it. It was very simple to put something like this together, and I hope you see the value in this. This was a very short, small example, but nonetheless, it works. So let me know what you think. Subscribe if not subscribed. And if you want to see more of this kind of content, let me know. I would love to hear from you. Thank you so much. Till next time, be well.